That mini quiz is next class. That's showing some justice there. Just do it, please. John, he's not gonna notice.
He's not.
He's not gonna notice we're here.
No, he definitely care. Didn't he like kick Johnny out?
No, he would never. Don't call yourself this.
Yeah, don't. That's what they're at.
Just make yourself a help, please.
I should tell him that I can't see the board forward. I'm gonna take it directly over the board.
So you're just gonna like hope we have time?
I think I'm
Do you want? I can show you my gist quizzes. I did it this morning at like 5 a.m.
See, he's never said that this ever.
How are we gonna do this?
Until we lose.
Sorry, give me just a second to get attendance put in. The internet's kind of slow right this second. Mason is here. Amelia. Wesley is parent contact. Brody. Okay, we need to get started here. We've got a pretty full period, so we are moving on into Unit 3. Last time I saw you guys, we finished up Unit 2 with the test. So the first major difference about Unit 3 is that this unit only has 2 sections. It'll be 4.7 and 4.8, whereas your first 2 units had 3 sections each. So in that sense, I guess it's a little bit less to the unit. But there's quite a bit to 4.7, so we'll spend 3 full class periods on this before we quiz. So that's what we'll be starting here today. And typically, most students think 4.8 is one of the easier things we do, but 4.7 is on the harder side. So I think in the end they kind of balance out, but this one that we're starting with today does have a little bit more going on with it. So for day 1, what we're going to do is we're going to go through the notes, talk about all the important stuff, finish number 36. Then we'll go to 37 and do questions 1 and 2 on that, which is the bulk of it, but those are the most important question types. And then I will ask you to do questions 1 and 2 from worksheet 2, which you can see looks very similar to that. There are 6 things that you will have to memorize in this unit, 6 things that are very important. So I've got a mini quiz next class to show that you have memorized those, and it is set up to be matching, so it's meant to be pretty easy 6 homework points. But you'll see as we go through, about the time we finish the notes, you'll start to see why it's so important that you have those memorized. So, okay, so 4.7 is all about inverse functions. So we've used inverse functions just a touch, but we need to go pretty in depth on this. So before I get going here, these 2 things are completely interchangeable, so you need to be familiar with that. Instead of saying inverse tangent, we might say arc tangent. Instead of saying arc cosine, we might say inverse cosine. Inverse sine and arc sine are the same thing, just different ways to write it. I think this is still pretty popular because if you wanted to like type this and you didn't know how to do the little exponent looking thing, then it's a good way to still type it out. So. Okay, so how we have currently been using the unit circle is a question like number 1. We tell you the trig function, we tell you the angle to go to. So the input, what's getting plugged into the trig function, is an angle. And we would go to that spot, think about the point, and take the y value because it's sine. But the output, this is a ratio. It's telling us for every 1 in the opposite length, there would be 2 in the hypotenuse length. So that is how we've used the unit circle 99% of the time at this point in the year. The input is an angle, the output is a ratio. Well, at the most basic, inverse functions really just mean you're swapping input and output. So now that we're doing inverse functions, the input is going to be the ratio, and what it's equal to, the output, is going to be an angle. So this is a very oversimplified way to answer this question. But this question is almost asking what angle has a sine of square root of 3 over 2. So you do have to be very familiar with the unit circle in this section, or become very familiar if you're not. But there's a few places where sine is square root of 3 over 2. One of them is at pi over 3. There's another one at 2 pi over 3. If you're willing to go all the way around the circle and then another pi over 3, that would be like 7 pi over 3 and 8 pi over 3, ... If you're willing to go around the unit circle multiple times, there's really an infinite number of places where sine is square root of 3 over 2. That being said, only one of these is the answer. So this is where it gets a little bit messier. So I need to show you why only one of those are the answer, how you're supposed to know what the answer is, and then we will see how to come up with the answer for the other ones besides arc sine. So this next little section, it is pretty wordy, but I really prefer for you guys to know where this stuff comes from. It'd be much quicker if I said, here's the 6 things you have to memorize, and start to memorize them. But I'm going to show you where they come from, so hopefully this sticks a little bit better. So the problem occurs, even in algebra, you probably had a teacher that said to find an inverse function, you just switch x and y. But what you're really doing is swapping the input with the output. So most of the time in algebra, you're talking about inverse functions, you switch x and y, because x is your input and y is your output. For us in trig, we are swapping the angle with the ratio. The angle was the input, the ratio was the output. Now that has been switched. Now what we really need are these inverse functions to be a function as well. For a function's inverse to be a function, it needs to be 1-to-1, which means it needs to pass the vertical line test, which makes it a function, and the horizontal line test, which guarantees that his inverse is a function. If you're not familiar with that word one-to-one, you might need to relearn that one because I know that shows up on the ACT. But a function's inverse is not a function itself unless it is one-to-one. So on the left over here, we know what sine looks like now. Just throw in a quick sketch. Is sine a function? Okay, it is. One is, it implies it by calling it f of x. And two, if it passes the vertical line test, we know it's a function. So sine is a function. Is sine one-to-one?
No.
Okay, because it does not pass the horizontal line test. I can draw at least one horizontal line that intersects it more than one place. So what we need is, we really need, for this to be useful in mathematics, for inverse sine to be a function, which means this needs to be one-to-one. So as it stands, his domain, we did this in 4.6, it goes forever left and forever right, and the range goes down to 1 and up to 1. But I need to ignore part of this function. I need to ignore part of it to make it one-to-one. So what we do is we just choose to ignore as little of the function as we can, but what's left behind needs to be one-to-one. Do you see how this leftover piece is now one-to-one? Passes both the vertical and the horizontal line test. So this trick in mathematics of just choosing to ignore part of the function is called restricting the domain. So the domain that we are restricting to is between here and here. Negative pi over 2 to positive pi over 2.
Why did you choose those coordinates? Does it matter, or is that just preference?
There's others that you could pick that would be one-to-one, but just like the mathematical community as a whole, we all agreed to do the same ones.
Okay, and it's pi over 2 or something.
For sine, it's negative pi over 2 to positive pi over 2. Now, if you tried to do this, like if you tried to keep maybe this part of the graph, this isn't one-to-one.
Oh.
So you couldn't do that no matter how much you wanted to. We have to cover up as little of the graph as we can, but what's left behind needs to be one-to-one. The reason why that's important, again, I can just tell you guys what they are, and I've done that some years, but this is the restricted domain, and how this helps us know something about inverse sine is that inverse functions are swapping input and output. So that also means it's swapping domain and range. So the restricted domain will become the range. This is one of the 6 that we absolutely have to memorize in this section. The possible y values, range, become the possible x values, domain. And on the right, this is just a typo. We don't need to restrict the domain on the inverse function. The range of sine becomes the domain of inverse sine. The restricted domain of sine becomes the range of inverse sine. And we will actually look at the graphing again next time, but we might as well go ahead and just make the graphs real fast too, because this is the bulk of the work here. So let's just make a graph. If this guy's domain is negative 1-to-1, I know that he should not exist left of negative 1 or right of positive 1. That's what domain's telling me. And if the range is negative pi over 2 to positive pi over 2, negative pi over 2 is as far down as it needs to go. Positive pi over 2 is as much up as it needs to go. One thing to notice, not only does domain and range switch to range and domain, but the axis values change too. Sine has an x-axis values in terms of pi. That ends up becoming the y-axis on the inverse. And on sine, the y-axis was in terms of 1, 2, 3, 4. So inverse sine, the x-axis would be in terms of 1, 2, 3, 4. If you're switching x's and y's, you're switching input and output, those switch as well. X-axis is in terms of pi, but now it's y. Y-axis was in terms of 1, 2, 3, 4, so now it's the x-axis in terms of 1, 2, 3, 4. But to graph this is the last little key you need for these. You can take a point on sine, like 0, 0, switch x and y, and that gives you a point on the inverse. But 0, 0 switched to still 0, 0. You could take another point, like pi over 2, 1, switch x and y, and that gives you a point on the inverse. So at 1 pi over 2, and maybe we could steal this point. At negative pi over 2, negative 1, inverse just means you're swapping the input and the output. So inverse sine would have a point at negative 1, negative pi over 2. And just like any graph, the more points you do, the better it's going to be. Try not to connect these into a straight line. Just like this, it kind of looks like a straight line, but it's really not a straight line. There's some curvature to it. Try to show a little bit of curvature here too. That's what the inverse sine graph looks like. Now this is different than other graphs in that this isn't just one cycle, that's the entire graph. Inverse sine only exists from negative 1 to 1 domain and negative pi over 2 to positive pi over 2 range. Yeah.
Is it possible to like stretch it and compress it, like move it across the graph? Like with regular time?
Is it possible? Yes, but that's not our focus in this section. You don't have to worry about that. The graphing is very, very little of this section. We're just doing it because we're talking about these anyway. Okay, so I'm going to do this with all 6 trig functions, and I know it's confusing at first, but you need to see what we did. We took a trig function we knew, we restricted the domain to make it 1 to 1. The restricted domain became the range became the domain, and then we know some stuff about the inverse function. So we're going to do the same thing with cosine. Cosine by default is not a 1-to-1 function. So we will restrict the domain so that it is 1-to-1. So before I restrict the domain, it's negative infinity to infinity. The range is negative 1 to 1. But again, this is not 1 to 1 yet, which means his inverse is not really a function yet. We really need it to be a function. So we will ignore as little of this graph as we can. That will still make it 1 to 1. And for this question, our restricted domain is 0 to pi. Include 0, include pi. So the possible y values, range, are going to become the possible x value domain. The restricted domain is just a typo. We don't restrict the domain here. And then the possible x's become the possible y's. The range of inverse cosine is 0 to pi. This is the second of the 6 things we have to memorize in this section. You don't know. Oh, yeah. Go ahead and finish copying that down. Sorry, I moved on a little too quickly from sine. You need to see why this is important. So with inverse sine, his range is negative pi over 2 to positive pi over 2. That's the only output y values that he has that exist. So if we go back to question number 3, which of these angles is within his range? His range is from negative pi over 2 to positive pi over 2. Which of these angles are between those two values? Pi over what?
3.
Pi over 3 is the one that's between those values. And that's why that's the answer to that question. And these are not the answer to that question. Inverse trig functions only have one unique answer. So, a minute ago, I said a oversimplified version of how to word this is it saying what angle has a sine of square root of 3 over 2. The full version of what it's asking is what angle has a sine of square root of 3 over 2 within the range of inverse sine, which is why we need to memorize that, because it tells you which one's your answer and which ones are not your answer. Okay, sorry. So go back to cosine. If we know his domain is -1 to 1, then I know how far left and right he goes, and I can make my graph look a little bit more zoomed in. And his range is 0 to pi. And if I want some specific points, if I want to graph this, just take some points from the function, like 0, 1, switch x and y, and they become a point on the inverse. So 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0 pi over 2. Pi -1 becomes -1 pi. Still as many points as you need to. Reconnect them and try to keep this same shape. Try to show a little bit of curvature there.
Why was this domain restricted from 0 to pi as opposed to pi over 2 as negative pi over 2 pi over 2?
Well, if we had done negative pi over 2 to positive pi over 2, it's not 1 to 1. It doesn't pass the horizontal line test. So that's just not a possibility on this one. So again, you could pick different intervals that could be 1 to 1. Like you could pick negative pi to 0, I guess. But again, just in general, mathematic community, we all agree to look at the same ones. So okay, so there's time number 2. Now I'm going to speed up a little bit. We know what tangent looks like. I'm not going to spend much time talking about what tangent looks like, because you should be able to do that if I gave you a minute. But we've already talked about his domain would be anything where there's not an asymptote. So pi over 2 plus integer multiples of pi. His range is forever down and forever up. But in this section, for inverse tangent to be a function, I need this to be 1 to 1. So I need to ignore part of the graph. And the part that I don't ignore has to be 1 to 1. Has to pass the vertical and horizontal line test. So with inverse tangent, we keep the negative pi over 2 to positive pi over 2. But notice it doesn't reach it on the left or the right. So those need to be parentheses. This restricted domain, the reason why I have it highlighted, and the reason why it's going to be important to us in this section, is because the domain of tangent becomes the range of inverse tangent. This is the third of 6 things we have to memorize in this section. And that's important because it tells me what kind of answers I should get for inverse tangent questions. Any inverse tangent question we do in a few minutes, the answer has to be between negative pi over 2 and positive pi over 2, or there's 0 chance it's correct. This is the only places inverse tangent exists. Okay, and then range, possible y values become domain, possible x values.
Domain, do I need to be brackets or parentheses is fine?
This domain?
The one on restricted domain on the left side.
Well, it doesn't actually reach negative pi over 2, so this has to be parentheses, and it doesn't reach positive pi over 2, so this has to be parentheses. Brackets would be incorrect.
Alright.
Okay, and then we might as well do the graph for inverse tangent because we're here. The domain tells us our graph should go forever left and forever right. Our range tells us it shouldn't go below negative pi over 2 or above positive pi over 2. And if we need specific points, we just take a point on tangent, switch x and y, and plot it on inverse tangent. So 0, 0, switched around, stays 0, 0. Pi over 4, 1 becomes 1 pi over 4. Negative pi over 4, negative 1 becomes negative 1, negative pi over 4. I'm just picking points. It's not that the points I'm picking are better or anything, but you can steal as many points as you want to, and it's going to end up looking like this. It has to go forever left and right. That's the domain. And the range, it can only approach this y value on the bottom and approach that y value on the top. So all of that is good to know, but the important part is highlighted. If you don't know the range of inverse tangent once we get to our next test, then it will be very hard to do well. Okay, so once again, we're going to think about what the cosecant graph looks like. Again, I'm just going to put it in quickly. I know y'all should be able to graph it on your own. We can quickly review that his domain was everywhere there was not an asymptote. His range was negative infinity to negative 1, and then 1 to infinity. This is a function because he passes the vertical line test, but his inverse is not a function because he doesn't also pass the horizontal line test. So, for cosecant, the part of the graph we choose to ignore is all of this stuff and all of that stuff. So we restrict a domain to here. But notice x can't equal 0. So we've got to split this into two parts. It goes from negative pi over 2 to 0, but don't include 0, and then 0 to positive pi over 2. That would be his restricted domain. That's the part of the graph I would have to leave. So that restricted domain ends up being the range of inverse cosecant. Possible x's become possible y's. Possible x's become possible y's. And there is the fourth of 6 that we have to have memorized in this section. And then the domain's much easier. The domain of the inverse function is the same as the range of the original function. Y values become x values. I don't count that as memorizing something new, personally. So the graphing of inverse sine, inverse cosine, and inverse tangent, again, we'll practice that again next class, and we probably will put 1 to 3 of those on your next quiz. We will not ask you to graph inverse cosecant, inverse secant, or inverse cotangent. But we're already here, so there's no reason not to just go ahead and follow through. I think the repetition is good for you. So I know this graph needs to exist to the left of -1 and to the right of +1. So my graph shouldn't exist here in the middle. And based on the range, it looks like he should go from negative pi over 2 up to 0. Shouldn't hit 0. And then 0 to pi over 2. And since this graph's a little less important, I'm going to go a little bit quicker here. But if I take a point on the cosecant graph, switch x and y, we could get a point at like 1 pi over 2. And you could steal some more points over this way. Another point you could steal would be negative pi over 2, -1. So that becomes -1, negative pi over 2. And you can still some other points, but it would look like this. Now, if you guys ever choose to do a college trig course, you probably would have to do that for them, but for us, this one's not as important.
So do you just do 1 over sine with the -1 calculator?
No,
Or it's 1 over 1 over...
no. Calculator stuff's next class. We won't get to any calculator stuff this time. Okay, next to last one. So we know what secant looks like. We're going to restrict the domain to make it 1-to-1, and then that's going to tell us some new information about inverse secant. Okay, there is secant. The domain we talked about in section 4.6, the range we talked about in 4.6, but this is not 1-to-1 until we restrict the domain. And with secant, we ignore this stuff and this stuff. So our domain comes from these x values. 0, which you can include, to pi over 2, which you cannot include, and then pi over 2, which you cannot include, to pi, which you can include. So 0 and pi need brackets because you reach those values. Pi over 2 should be in parentheses because you only approach those values. Now, I guess there's nothing stopping you from deriving this stuff on the quiz, but it's pretty time consuming. So ideally, you're going to memorize that this becomes this, and I've got some hints and some patterns that help you see that. But this would be the 5th of the 6 things that we will have to memorize in this unit. Just for completion's sake, let's just go ahead and fill in the rest of the domain and range stuff. The range becomes the domain. Knowing the domain and range of inverse secant helps us graph it because we know that he exists to the left of -1, to the right of +1, so he's not going to exist between those. And the range, 0 to pi over 2, and then pi over 2 to pi. So he should only exist between these y values and not outside of that. Yes?
Why do you put the little u, like between the two points?
What is this u?
Yeah.
That's a math symbol for the union. It's a u for union, just a fancy way to say and. If you want to just use the word and or use the comma, that's fine. Okay, and then if you ever needed to graph inverse secant, which again, we will not ask you to do this, but you could take a point on secant like 0, 1, switch x and y, and that gives you a point on inverse secant, 1, 0. And then you could do other points. Again, I'm not too concerned about this graph just because we don't make you guys do it, but you can copy over as many points as you want. That's what inverse secant looks like. Largely, instead of just telling you the domain and range, I'm trying to help you see how knowing the domain and range almost completes the graph for you. Alright, and then finally, cotangent and inverse cotangent. And then we can actually start to practice some of this and start to get it to make a little more sense here. So, cotangent was the one that looks like this. He existed everywhere. There was not an asymptote. his range was from negative infinity to positive infinity. But if we want his inverse to be a function, we have to restrict the domain. So we will ignore most of the graph. What we keep behind has to be 1 to 1. And what we leave behind is 0 to pi. It only approaches 0 on the left and it only approaches pi on the right, so those both have to be parentheses. This restricted domain becomes the range of his inverse function. Possible x's become possible y's. The range becomes the domain because possible y's become possible x's. And again, we will not ask you to do inverse cotangent at any point in this class, but if you know the range is 0 to pi, you know that where the y values exist. If you know the domain's negative infinity to positive infinity, you should know the graph goes forever left and forever right. And based on this being the 6th question, you should know how to get some points. Cotangent has a point pi over 2, 0. So that means inverse cotangent would have a point 0 pi over 2. Cotangent has a point 3 pi over 4, negative 1. So negative 1, 3 pi over 4. It's got a point 1, or pi over 4, 1, so 1 pi over 4. It's going to look like that. That matches his domain and range. And I'm sure 3 of those points are correct. And the general shape of the graph should not change drastically. Still going to look, it looks kind of like it's been turned and flipped. It's still kind of the same shape though. So all of those 6 ranges of inverse trig functions are the ones we need to memorize. Realistically, you don't want to have to go through all of that work. I did that for you one time so that I'm not just telling you to memorize them and you have no context of where they're coming from. But on this page, I've got a different way to visualize these for you. And I know this says inequality, but we're going to do interval notation. And we're going to do what's called like a unit circle visual. So this is all about the ranges. The domain is important too, but the ranges are the ones we're going to live and die by in this section. So the very first one we did, we said that the range of inverse sine was negative pi over 2 to positive pi over 2 with brackets. So if you pretend like this is a unit circle diagram, that would be from here, negative pi over 2, to here, positive pi over 2. So I memorized that one, and then I know his reciprocal is the exact same thing with the hole in the middle. Negative pi over 2 to 0, don't include 0, and then 0 to pi over 2. Same thing we did on the other page, but I'm not deriving it. I just know that it looks the same, but it's got a hole in the middle. And then tangent's the other one that cares about quadrants 1 and 4, and he doesn't exist at the endpoints. So that would be negative pi over 2, positive pi over 2, but they were both parentheses. So I'm not saying anything different than what we did on the last 2 pages. I'm just summarizing it in a much more concise way. These 3 all use quadrants 1 and 4. Inverse sine, his reciprocal has a hole in the middle, and inverse tangent has holes at the endpoints. Along that same pattern, you can do the same thing with these 3. All 3 of these, like quadrants 1 and 2, but cosine is 0 to pi. His reciprocal is 0 to pi, but there's a hole in the middle. So we have to skip pi over 2. And inverse cotangent cares about quadrants 1 or 2, 1 and 2, but he has holes on the endpoints, just like inverse tangent has holes on the endpoints. So 0 to pi. the same 6 ranges of inverse trig functions we did on the other page, but summarized in 6 pictures. There's other patterns as well. If you remember your cofunctions, sine and cosine are cofunctions. So do you see how you could like take this one and turn it this way, or take this one and turn it this way and you get the other one? Can you visualize that? Okay, these two are cofunctions, so you could just turn one and get the other one. These two are cofunctions, so you could just turn this one up or turn this one down and get the other one. And these two are cofunctions, so if you turn this one, you get this. If you turn this one, you get that. But this visual, not the only way to memorize these, but by far the most efficient for students. So, all right, finally, before we move on to worksheet 1 and practice a bunch of these questions, I need you to know that the bulk of the stuff we do in this section boils down to one of 2 types of questions. Some of these will be unit circle type questions, which we will look at here, just one example here. And if it's not something from the unit circle, it's one that we will need to sketch a triangle on, and we'll do one example here. But we'll do several of each of these on worksheet 1 in a minute. So this question is saying, tell me the angle that has a sine ratio of -1/2 within the range of inverse sine. So for these question types, you should make a little unit circle picture. You should make one trip around the unit circle and label everywhere where you think sine is -1/2. That's about a 2-second step if you really know the unit circle. One trip around the circle, label everywhere where sine is -1/2. The second step is you should draw in the range of inverse sine. What is the range of inverse sine?
Negative pi over 2 to pi over 2.
Negative pi over 2 to positive pi over 2. You should draw that on your diagram, because that repetition and doing that every question helps you memorize those 6 that you have to, and it gives us a visual. Our answer is going to come from this location and not that location. Okay, and then finally, what do we normally call this angle? This spot.
Quadrant 4.
That's the whole thing. But what's this angle location?
330 degrees.
Okay, but we want it in radians.
11 pi over 12. No.
11 pi over 12 is less than 1.
6. 11 pi over 6.
Okay, you normally want to call this 11 pi over 6. It's 1 pi over 6 to be in 2 pi. But you should put this on your paper and you should put an X through it. That's the right spot, and that's one way to name that angle. But the last step in these question types that can be kind of tricky is your answer has to be within the range of these. So you can't call that 11 pi over 6. You need to name that same location that's between these two values. So what's a different name for that angle?
Negative pi over 6.
That's the one and only answer. Inverse functions, the whole point of restricting that domain is to narrow it down to one specific answer. Our answer has to come from the range of inverse sine. So again, we're going to practice a handful of these, but you're going to notice that the less comfortable you are with unit circle, the harder these can be. The longer you drag your feet on memorizing the range of the 6 ranges of the inverse trig functions, the harder these can be. But otherwise, they don't really take a lot of work, so I kind of like them. Okay, the other question type that's going to come up a lot is stuff that's not unit circle. So on this one, I knew this was unit circle because -1/2 is a ratio I'm familiar with on the unit circle. Over here, the ratio was 2x over 1. There's no spot on the unit circle that I memorized that has a fraction of 2x over 1. So the only thing you can do in these question types is to sketch a triangle. So this outside piece cosine will carry along for the ride. But all of this we have to make a picture for. So, what quadrants does inverse sine care about?
1 and 4.
1 and 4. And in quadrant 1, sine is positive, and in quadrant 4, sine is negative. So if this was inverse sine of something positive, like positive 2x, we should sketch a reference triangle that's in quadrant 1. But if it had been inverse sine of something negative, I would need to make my triangle look like it's in quadrant 4. Sometimes you can still get lucky if you don't make them in the right quadrant, but we need to practice for consistency. And then all of these questions will finish with the same 3 steps. SOHCAHTOA, Pythagorean theorem, SOHCAHTOA. So the first SOHCAHTOA is using these 2 sides. Sine is opposite over hypotenuse. You will need Pythagorean theorem for the last side. And if this is in terms of x, this is going to be in terms of x. So don't freak out that it's not all numbers. And then finally, the last SOHCAHTOA, you get to worry about this. This wants to know what's the cosine of that angle, and cosine is adjacent over hypotenuse. So the answer to that question would be the square root of 1 minus 4x squared. All I need you to see out of this question right now is that 2x over 1 is not a unit circle ratio, and that's how I knew I had to make a triangle. Okay, so let's slide over to worksheet 1 where we can start to get more repetition in. And again, we're going to go through questions 1 and 2 together. 1 is the chart, and 2 is a combination of 4 or 5 of these unit circle questions and 4 or 5 of these sketch a triangle questions. And then I will ask you to do the same question types on worksheet 2. Okay, so question number 1. So we have always put this on the quiz and the test, so it's a good handful of points. But this part really shouldn't feel new to you. I know we have it in your notes. But the domain of the inverse trig functions is the same as the range of the regular trig functions. Question. So the fact that I know the range of sine, cosine, tangent means I really also know the domain of inverse sine, inverse cosine, inverse tangent. There wasn't no restricting going on in that. So this is just straight up memorized from 4.6 and then understanding that those ranges become the domains. So sine and cosine had a range of -1 to 1. So that becomes his domain in the inverse. Tangent and cotangent had ranges of -infinity to +infinity. Those are now the domain of their inverses. And the range of secant and cosecant were -infinity to -1 and 1 to infinity. The range of the regular trig functions become the domain of the inverse trig functions. Those are important, but those are not near as important as the ranges are going to be. Again, I know that's on our 4.7 quiz, which is like 3 class periods away. And I think some years we might count this as 3 points, and some years we count it as 6 points. But in theory, you should know them already. Make sure you write yourself a little note and where those came from. For the range, these are the 6 that we just spent basically the first half of class on and summarized on the back page. For me, I know that sine looks like this, -π/2 to +π/2. I know his reciprocal looks the same, but it has a hole in the middle. -π/2 to 0 and 0 to π/2. And tangent looks the same, but undefined at the endpoints. Then I know cotangent cares about quadrants 1 and 2, 0 to pi. If reciprocal is the same, but it has a hole in the middle. So 0 to pi over 2, and pi over 2 to pi. And then cotangent also looks the same, but holes at the endpoints. Again, I can answer all 6 of those with very little hesitation, but those are the ones that are super important. We will just straight up ask you, what are these on your 4.7 quiz, and that might be 3 to 7 points, but I'm going to put a bunch of stars by these, because you're going to see, if you don't know these, you're going to miss a lot of the questions in part 2, question 2, because our final answers have to land within those values. Okay, at the start of class I had mentioned that I had made up a quick 6-question mini quiz that is just matching, and this is all that the mini quiz will be over. So you might want to write in words that this is what you need to review. But I will put the unit circle picture and the interval notation, and next Tuesday you need to be able to match that up with inverse sine. I will
Whole quiz, range.
just the range, the 6 ranges. You need to be able to match up the unit circle picture and or 0 to pi with brackets with inverse cosine, and it's all matching. So honestly, you need to know much better than that, but I'm trying to incentivize you to memorize them sooner rather than later. So,
You need to know like top one is sine, second cosine.
well, they're not going to be in the same order.
Or no, never mind.
Like, the quiz is going to be like, I don't know, choice C is going to be this, which is this, and then you need to tell me choice C goes with what inverse trig function,
Okay.
which is what? Inverse sine. This will be the question. This will be the answers to pick from.
Gotcha. Okay.
And again, matching should make that pretty easy. And it's only 6 homework points, but my 8A class already did it, and it was fine. But these are the ones we need to know for sure. So, any questions about this before we dive into specifics? Okay, so then on the end of our notes, we talked about the 2 major types. There's unit circle questions, and there's sketch a triangle questions. So, number 2, is there anywhere on the unit circle where sine is -1? Okay, then we should go around the unit circle and mark everywhere where sine is -1.
Yep.
Sorry?
It'll be the 0, 1, and 0, -1, right?
Sine is +1 here, not -1. Step 2, draw in the range of inverse sine. Inverse sine is -pi/2 to +pi/2. Your answer is going to come from the spot where sine was -1 within the range of inverse sine. So what is this angle here? Okay, what do we normally call this angle?
Oh, 70 degrees.
Okay, we're doing everything is in radians with inverse trig functions. Okay, normally we call this 3π/2, but 3π/2 is not between -π/2 and +π/2. You have to think of a different way to name that spot that's within these values. And that's the one and only answer. You have to know the unit circle to know where sine's -1. You have to memorize the range of inverse sine to know where your answer comes from. And the last step is you have to be careful that you pick an answer between those and not just the right spot. Okay, I'm going to come back to B just because tangent's always a little bit more work. But C, inverse cosine of negative square root of 2 over 2. Does that sound like a ratio from the unit circle?
Yes.
Okay, then make a little unit circle, go around it, and mark everywhere where you think cosine is negative square root of 2 over 2. I will be more patient sometimes, but if you know the unit circle, that's all the time you should need there. Step 2, draw in the range for inverse cosine. Inverse cosine is 0 to pi. Drawing it in helps you memorize it, and it gives us a visual. This location is not our answer. This location is where our answer comes from. And what do we normally call this angle in the middle of quadrant 2?
3 pi. Over 4.
Okay, and is 3 pi over 4 between 0 and pi?
Yes.
Then that is fine as the final answer. We didn't have to get creative with how we named it. This question is asking you what angle has a cosine of negative square root of 2 over 2 within the range of inverse sine. That's what it's asking us to do. Okay, on D, this is one with 2 layers, but like we saw in the notes, doesn't really matter. We'll just worry about tangent later, and we'll do this part first. Does negative square root of 3 over 2 sound like something from the unit circle? Okay, then draw a unit circle, go around, and label the spots where you think cosine is negative square root of 3 over 2. Yep. So that would be here and here. Step 2, draw in the range of inverse cosine, 0 to pi. That shows us our answer doesn't come from here, it comes from here. And what is this angle? What location is that angle at? Okay, so all of that was just to do the inside of that question. At the end, you can worry about the outside layer. At the end, it just wants to know, hey, what's the tangent there? And if you did sine divided by cosine there, you would end up with negative square root of 3 over 3. So I think I may have shown this to you once, but I want to kind of try to sell it to you again, because I want you to see how it makes this instant. I didn't actually have to do sine divided by cosine, and it will help us with B and E. And that is if you were willing to memorize the tangent values. In the middle of each quadrant, what is tangent equal to? That's what sine is equal to. Sine and cosine are both square root of 2 over 2, so something divided by itself is 1. Or, depending on the quadrant, negative 1. If you did sine divided by cosine for the spots near the y-axis, you get the square root of 3, or negative, depending on the quadrant. And then the spots near the x-axis are smaller. They are square root of 3 divided by 3. And again, some quadrants it's positive and negative. But that's it. That's the only ones of tangents you really need to know. I mean, I guess the quadrantal angles sometimes, but those have a 0 in them, so those are easy. Also notice that directly across is always the same value. If you know that some angle has a tangent of negative 1, directly across the circle also has a tangent of negative 1. And again, all I really do is think about the signs. The ones near the x-axis on the unit circle are divided by 3. The ones near the y-axis are not divided by 3. And the ones in the middle are 1. It's pretty easy to memorize. Now, and in the end, that's a lot less work. Right here, I knew this was negative because of the quadrant. And because it was next to the x-axis, I knew it was going to be square root of 3 over 3 without actually doing sine divided by cosine. So if we go back to b, you can see how much easier this is. This is a ratio for tangent on the unit circle. And since this is just the square root of 3, I know it's one of the spots near the y-axis. But what quadrants is tangent negative in? 2 and 4. So there's the two places where tangent is negative square root of 3. If you don't memorize the tangent values, you can still get the answer right, but what you're going to have to do is you're going to have to say, well, in quadrant 1, tangent's positive, and quadrant 3, tangent's positive. These are the only two quadrants tangent's negative, and then you have to do guess and check. You could try this in the middle, do sine divided by cosine, see it's not what you want. You could try this one, do sine divided by cosine, see it's not what you want. And then eventually you've got to try this one, do sine divided by cosine, and see it is what you want. So if you're a lucky guesser, you can do that quicker, I guess, but it's much more convenient to just have those memorized. Okay, so found the locations of inverse tangent. Drawing the range of inverse tangent is negative pi over 2 to positive pi over 2. Don't include the endpoints. So my answer does not come from this spot, it comes from that spot. You're going to want to call that angle 5 pi over 3, but 5 pi over 3 is not between negative pi over 2 and positive pi over 2. So instead of calling it 5 pi over 3, you're going to have to call it negative what? Very good. Negative pi over 3. It's coterminal to it, but it's within the right numbers. Okay, one more of this question type, and then we'll look at the other question type. Okay, E, the outside is going to be an inverse trig function. The inside, this is what you've been doing since like week 2 of school. This is not an inverse. This is just saying go to 2 pi over 3 and give the tangent value. Well, 2 pi over 3 is here. I just talked about how to memorize those, so do sine divided by cosine if you want to or if you're unsure. But in this quadrant, he's negative, and since he's near the y-axis, it's square root of 3. That's all you really have to do if you memorize the tangent values. Now, inverse tangent wants me to list off everywhere where tangent is negative square root of 3. Well, of course that's 2 pi. Does that mean my answer is 2 pi? It's pretty similar, yeah. Okay, so if this spot has a tangent of negative square root of 3, how would I know where else has a tangent of negative square root of 3?
Opposite.
Right, directly across we'll have the same tangent value, so the same cotangent value as well. Drawing the range of inverse tangent, it's negative pi over 2 to positive pi over 2. So my answer is going to come from here, not there. And you have to name it, not just any way you feel like. It's got to be within the range of inverse tangent. You have to say negative pi over 3. Now we're not doing any calculator stuff with this today, but even your calculator understands that. You type that in your calculator, hit enter, it's going to give you one answer only, and it's going to be a decimal, but it's going to be the same as this decimal. So even your calculator has these ranges memorized. Okay, so this is almost half of the questions in this section. The ratio is something on the unit circle. You mark them all. Draw in the range that you have to memorize. That shows you where your answer comes from and doesn't come from. And then be careful that your answer falls within the ranges that you memorize. The other question type is like F. And at first glance, it doesn't look any different, but it's going to work out completely different. Negative 2 is not a tangent value that I memorize on the unit circle. It doesn't mean that it doesn't exist. If you think about the unit circle, I mean, we memorize 3 points in each quadrant, but there's 360 degrees. We memorize very little of it. We just memorize the most common ones. But in our notes, we talked about if it's not something from the unit circle, then we need to sketch a triangle. So we'll have to spend a few minutes on this question, but after we do a couple of these, you should be spending no time to realize you need to sketch a triangle. Now, I need to sketch my triangle correctly, so let's put some thought into inverse tangent. What quadrants does inverse tangent care about?
1 and 3. Or, 2.
Not 2 either. 1 and 4. Like that. So, in quadrant 1, tangent's positive, and in quadrant 4, tangent's negative. So if this was inverse tangent of something positive, I would want to make my triangle look like he's in quadrant 1. But this is inverse tangent of something negative, so I need to put it down in quadrant 4. We can think of negative 2 as a fraction, 2 over 1, and tangent is opposite over adjacent. So there's SOHCAHTOA number 1. By the way, when a number is negative like this, you should not assume that the negative goes with the 2, by the way. When we do fractions, you could make the numerator negative or the denominator, or you can put it out front. You can write it any way you want to. You can't assume that the 1's negative or the 2's negative just based on where the negative is. This is where the picture comes into play. This is going right 1, so this is positive. This is going down 2, so that one's negative. That's how I know that one's negative. So there's SOHCAHTOA number 1. After that will be Pythagorean theorem. And it's not super satisfying, but the whole inside of this question is this angle. This is saying an angle that has a tangent of negative 2. And because my opposite to my adjacent is negative 2, this picture represents the whole middle of this question. To answer this question, we don't want a picture for an answer. We want to know what is the cosecant of this angle. So cosecant would be hypotenuse over opposite. So SOHCAHTOA number 2 to get your final answer. Was not a unit circle ratio, so I had to sketch a triangle. Okay, so next question, does negative square root of 2 over 3, does this sound like a unit circle ratio? Okay, I would say it does sound like one, but it's not actually one, right? Square root of 3 over 2 is on the unit circle. Square root of 2 over 3 is not on the unit circle. So that's not a problem. It just means that we're going to have to sketch a triangle to move forward. I can't tell you this angle because I don't memorize this angle. I don't memorize an angle that has that sine ratio. But sine cares about quadrants 1 and 4. Inverse sine does. In quadrant 1 he's positive, in quadrant 4 he's negative. So if this was inverse sine of something positive, I would draw him in quadrant 1. But this is inverse sine of something negative, so I should put him in quadrant 4. SOHCAHTOA number 1, sine is opposite over hypotenuse. Hypotenuse is always positive, and going down makes this guy negative. Once again, you should not assume whether the negative goes with the 3 or the square root of 2. That's why the picture comes into play. Pythagorean theorem to find the other side. And this picture of this angle represents the whole middle of this question. This is an angle that has a sine of negative square root of 2 over 3 because his opposite to his hypotenuse is negative square root of 2 over 3. To finish the question, we have to do SOHCAHTOA one more time. It wants to know what's the cotangent of that angle, and cotangent would be adjacent over opposite. And in this section only, we won't count it wrong if you don't rationalize. So if you want to leave it like that, you can. If you want to rationalize it, that's fine too. But this is one section we don't make you rationalize just because there's so much other stuff going on. Main thing you need to get out of this, not a unit circle ratio, so sketch a triangle. Every sketch a triangle question is going to finish with SOHCAHTOA, Pythagorean theorem, SOHCAHTOA. Okay, for H, inverse tangent of X, is that a ratio on the unit circle? Then we better sketch a triangle. It doesn't matter if it's numbers, it doesn't matter if it's variables. If it's not on the unit circle, then it's not a unit circle question. If it's not a unit circle question, we need to sketch a triangle. Okay, what quadrants would we maybe sketch it in for inverse tangent? 1 or 4. 1 if it's something positive, 4 if it's something negative. This is implied as a positive x, so we should try to sketch a triangle in quadrant 1. Think of x as a fraction, put it over 1. Tangent is opposite over adjacent. There's SOHCAHTOA number 1. Then comes Pythagorean theorem. If this side's in terms of x, this side's probably in terms of x. Doesn't make Pythagorean theorem any harder. And then finish with SOHCAHTOA number 2. I want to know what's the sine of that angle, so opposite over hypotenuse. And if you don't feel like rationalizing in this section, that's fine, but it also only takes 2 more seconds. So
You would have to rationalize in this section.
in this section, I will not count it wrong if you don't. So you would think that it not being a number would be harder, but it's still the same process. I still had to put the same thought into where to draw the triangle, why to draw the triangle, still SOHCAHTOA twice and Pythagorean theorem once. Okay, I know I'm doing the bulk of this, but you guys are going to get to practice 5 or 6 of each of these on the next worksheet. So, okay, x over 6, is that on the unit circle? X over 6 is not something we memorize on the unit circle. So instantly I know to draw a triangle. Inverse sine exists in quadrants 1 and 4. Draw it in quadrant 1 if it's the inverse sine of something positive. Draw it in 4 if it's inverse sine of something negative. This is an implied positive x over 6. SOHCAHTOA 1, opposite over hypotenuse because they gave a sine. Pythagorean theorem. For the other side, it would be the square root of 36 minus x squared. And then SOHCAHTOA number 2 for your final answer. Cosine of that angle would be adjacent over hypotenuse. Okay, and I know, or I hope that there's a question you want to ask about that answer. Is there anything about this you would want to try to do more on? Yeah. 6 what?
36 is square root of 6.
Okay.
X squared. Could it be, what did the square root of that?
Yeah, so the temptation here is to say that this equals the square root of 36 and then minus the square root of x squared, this, right? That's not correct though. That's not how that works. When you take the square root of terms, things being added or subtracted, you can't do those individually. The quickest way I can show you that is to do this one. If you think that works that way, you should be able to do the square root of 9 plus the square root of 16, and you would think the answer is 7, but really this is the square root of 25, which is really 5, right?
Oh, right. You have to do the operations inside the operation, right?
Correct. Yeah, so you have to leave that alone. Leave that as is. You can't simplify the square root of 36 minus x squared. I know it's tempting, but it does not go further. Okay, 3 more we'll do together. So J, the inside part is not new. It's not an inverse function. We just need to think about at 4 pi over 3, what sine is. That's no in the unit circle. Then because this is a unit circle ratio, now it fits like the first 5 we did on the other side. Go around the unit circle, label everywhere where sine is negative square root of 3 over 2. Well, wait a second, don't these just cancel? Shouldn't the inverse sine of 4 pi over 3 cancel and give us 4 pi over 3 as an answer?
Should, right?
It's not in.
Right, it's not in, so sometimes yes, sometimes no, it depends on the angle. You should not be trying to take that shortcut. The range of inverse sine is negative pi over 2 to positive pi over 2. My answer comes from here, not from here. So that's why 4 pi over 3 can't be your answer. But also, don't name this 5 pi over 3. You need to name it negative pi over 3. You have to name it within the range of inverse sine. If your answer is not within the range of inverse sine, there is 0 chance it's correct. Okay, on K, this one does not look like a unit circle question, but if you try to sketch a triangle, you're going to hit a wall anyway, because this wants an angle answer. Inverse questions want an output of an angle. And looking at a triangle doesn't help you see the angle. So the trick to this one is you can change this from inverse cosecant to inverse sine as long as you do the reciprocal ratio. But the ratio is the inside part now. This next step, though, should emphasize to you why we are so picky about rationalizing. This still doesn't look familiar to you, but if you're willing to rationalize and multiply the top and the bottom by the square root of 3, what's left behind does look familiar. So, just to be truthful with you, in calculus we basically never rationalize denominators, but in trigonometry we need to, because if we don't, this doesn't look familiar until we rationalize it. We need it to look familiar. Now this is a unit circle question. Sine is negative square root of 3 over 2 in 2 places. The range of inverse sine is negative pi over 2 to positive pi over 2. So my answer comes from here, not from here. Don't call it 5 pi over 3, call it negative pi over 3. Okay, and then one more, and then I'll try to give you a few minutes to do a couple on worksheet 2. All right, inverse cosine of the sine of 7 pi over 6. If it has more than one layer to it, deal with the outside layer later. Do the inside layer first. This is regular sine. This is not new. If we go to 7 pi over 6, the y value there is negative 1/2. Then what's new is I can go around the unit circle and mark everywhere where cosine is negative 1/2. Draw in the range of inverse cosine, is 0 to pi. This lets me see where my answer comes from and doesn't come from. And then we need to name this angle in a way that it's between 0 and pi. So what would we call that spot? 2 pi over 3. That's how you would do that. So you can see these take a little bit more practice before you start to feel confident on them. But the 2 things I need y'all to do between now and next Tuesday is you need to memorize the range of the 6 inverse trig functions well enough to do a matching quiz. And on worksheet 2, I need you to do the same question types that we just did on worksheet 1. So question 1 is exactly the same question as number 1 on worksheet 1. So don't just copy the answers over, use it as a opportunity to quiz yourself. And you need to do all of question 2. So some of these are unit circle type questions. A couple of them are triangle type questions. So the chart, the table, and 12 other questions. So 2 things we will do for sure next class is the mini quiz right away. You definitely need to write that down so you don't forget about it, especially with the long weekend in between. And I will take your homework questions from worksheet 2, questions 1 or 2. You don't need to do questions 3 or 4 yet. 3 is some true or false stuff. 4 is using a calculator. We haven't done any of that stuff yet, so don't worry about those. Okay, so go ahead and try a couple of those on worksheet 2 with your time you have left. And I will make my way around the classroom here in just a minute. So if you have any immediate questions, I'll try to help clear those up for you before you go.
real quick while you're still here? Okay. Don't. You gotta be 18 to do that.
I'm faced.
You get to be my age. I think back when I was like 25 and I thought I was an adult then, but there's pleasure for sure.
You don't see anything that can just help us?
Anything that can help clear up for you for that?
What you get to drink?
Vanilla Coke. What do you get from Sonic?
Depends on the day. It's a hot summer day. You can get like cherry slushy, icy.
Okay. I don't get any of their slushies.
You should try it, it's really good. You get like a medium, you don't need a large, that's a lot of sugar, but a medium one, nice on a hot day.
Yeah, a lot of sugar makes me feel bad because I don't eat a lot of sugar.
I don't. However, another thing that's good is like, things that are called, like hand mix shakes. It's like you can get 61. John, you Sonic?
I don't know if that's a shake if they're putting candy bar in it.
Shake, Sonic, you know?
No.
I'll pull it up.
I think that's the ice cream at that point.
It's really good.
All right, guys, y'all have about 3-4 minutes left. So you need to find a stopping place. Again, before you pack up, make sure you write down where you need to be by Tuesday. Questions 1 and 2 on worksheet 2, and the 6-question mini quiz. If you're not sure what that's over, please come and ask before you head out so that you know what to study.